Welcome to Miss Perry's online physics lectures. Today's lecture will be about acceleration. When calculating acceleration, acceleration is equal to the rate of change of your velocity. In order to calculate that, you would take the change in velocity, so final velocity minus initial velocity, divided by time. Velocity measured in meters per second, time measured in seconds, and acceleration would be measured in meters per second, or meters per second squared. A sample problem. Find the magnitude of the acceleration of a car that goes from rest to 100 kilometers per hour in 10 seconds. My first step is to write my equation. This equation can be found right on the reference table. Acceleration is equal to change in velocity over time, which translates to final velocity minus initial velocity divided by time. Next, substitute numbers and units. 100 kilometers per hour was my final velocity, minus my initial velocity of 0 kilometers per hour, divided by 10 seconds, gives me an acceleration of 10 kilometers per hour per second. Let's try another one. Find the magnitude of the acceleration of a car that goes from rest to 10 meters per second in 2 seconds. First, we write our equation. Acceleration is equal to change in velocity over time, or final velocity minus initial velocity over time. Substitute numbers with units. Final velocity, 10 meters per second, minus our initial velocity, it was started from rest, so 0 meters per second, divided by our time of 2 seconds, which gives us a final acceleration of 5 meters per second, or 5 meters per second squared. So, what does it mean to say that an object is accelerating at 5 meters per second squared? I like to think of it in terms of 5 meters per second. Remember, acceleration is the rate of change of your velocity. How many meters per second it changes each second. So 5 meters per second squared is telling you that your object is changing its velocity by 5 meters per second. Each second, the velocity changes by 5 meters per second. This could either be speeding up or slowing down. For example, after 1 second of motion, this object could either have a velocity of 5 meters per second greater than its initial, or 5 meters per second less than its initial velocity. But no matter what, remember, never ever ever say the D word. Slowing down counts as accelerating. If you're accelerating, you can be speeding up, you can be slowing down, and also you could be changing direction. And again, I like to think of it in terms of 5 meters per second. Each second, the velocity changes by 5 meters per second. Whatever sign your velocity is, tells you the direction the object is moving. The sign for acceleration tells us the direction for the change in velocity. Because of this, a positive acceleration doesn't always mean that your object is speeding up. Also, a negative acceleration doesn't always mean that your object is slowing down. Let's go through an example so you can see what I mean. Imagine that you have a ball in your hand and you're going to throw it up into the air and then catch that ball at the same location that you threw it up. That ball is going to be accelerated by gravity. Gravity is going to force the ball to fall back down into your hand. And the acceleration due to gravity is a constant 9.81 meters per second squared. I'm going to assign an arbitrary direction. I'm going to say that anything traveling upward is positive. Anything directed upward is positive. Therefore, anything directed downward would be negative. Now, since gravity always acts downward, gravity is going to be negative 9.81 meters per second squared. My velocity vectors I will draw in green, and my acceleration vector I will draw in red. I'm going to draw a motion diagram for the motion of this ball traveling up and then landing back down in my hand. Starting with 0 seconds. I'm going to throw that ball up in the air with some big initial velocity. It's leaving the palm of my hand with some large initial velocity. And my acceleration is pointing downward because acceleration is due to gravity. Notice how my acceleration vector is negative. It's pointing downward. And my velocity vector is positive, pointing upward. After 1 second of motion, my velocity vector is still pointing upward, but it's gotten a little smaller. So my object here is slowing down. My acceleration vector is the same size and direction that we started with, because gravity can never change. The size of your gravity vector won't change, and gravity always acts downward, so that vector remains pointing downward. The key thing here is noticing that since our velocity and acceleration vectors are pointing in opposite directions, that tells us that our object is slowing down. After 2 seconds, it's slowed down even more. My velocity vector is a bit smaller, but my acceleration vector is still the same size. They're still pointing in opposite directions, so that object is slowing down. Another key point is noticing that my velocity vector is pointing upward. The direction your velocity vector points will always tell you the direction your object is moving. Since my green arrow for velocity is pointing upward, that means my object is traveling upward. When we reach 3 seconds, notice that I only draw an acceleration vector. That must mean that the velocity at 3 seconds is equal to 0 meters per second. As that ball continues its path, it begins to fall back down to where it started. Notice now that my velocity and acceleration vectors are pointing in the same direction. Both are pointing downward. Since the velocity vector is pointing downward, that means my object is traveling downward. It's moving down. Also, since they're pointing in the same direction, that means that it's going to be speeding up. After 5 seconds, they're still pointing in the same direction, but my velocity vector is getting a little larger until it finally lands back where it started at 6 seconds. So overall take-home message here. The direction your velocity vector points tells you the direction your object is moving. If your velocity and acceleration vectors are pointing in the same direction, you're speeding up. If your velocity and acceleration vectors are pointing in opposite directions, you're slowing down. To sum it up, repeating what I just said, if acceleration and velocity have the same sign, the vectors are in the same direction, you must be speeding up. However, if they have the opposite sign, positive or negative, opposite directions, that means that your object is slowing down. And don't forget, you can also be accelerating by changing directions. 3 different ways you can be accelerating. You can be speeding up, slowing down, or changing direction. If you have any questions, comments, or concerns, please feel free to ask me during class or after school.